Our session for today with GenAI Introduction. So as you know that last day we talked about AI/ML as well as deep learning. Let us just uh, remind ourselves another 5 minutes. Just repeat the session for 5 minutes, what we have done last day, and then we'll move with today's topic. So as you see here that last day we have started our discussion with AI/ML, right? Last day we started our discussions with the AI/ML introduction, and what we say is that uh, using AI/ML we can deal with huge amount of data. That is the big data. Today in this industry, current industry, dealing with the data in zettabyte scale, we cannot manage this huge amount of data using traditional human devices as well as traditional human approach. We have to store this data. We have to analyze this data with the help of ML, right? Next, we talked about the different organization, different businesses that is using today machine learning and AI, right? So we talked about the benefits of ML, right? So it will help us to take faster decisions. Now, how we can define machine learning? That it is one type of subfield of computer science that will give computer the ability to learn without being explicitly programmed. And what we find here is that using machine learning is used to find the pattern in the data, and using this pattern, it is going to create a model, and that model is used to do the prediction, right? So here what we do is that we want a machine to learn as human being learn identifying the pattern inside an object. Same like that, we want machine to learn. We'll build the model, and the model will help us to do the prediction. And related to that, we talked about two types of datasets last day. One is relational type dataset, another is image type dataset. So machine learning or machine can do the prediction not only for relational data, but also for non-relational data like images also. So related to that, what we told about is that machine learning algo will find the pattern in the data. Then we're going to build the model. And this model is used for prediction that we do in case of traditional machine learning, right? Now, next we talked about is that this machine learnings are two types. One is called supervised learning, another is called unsupervised learning. In case of supervised learning, what we say is that we have been given input and output both, right? We have been given input and output both, right? And there is two types of supervised learning. One is called classification, another is called regression. In case of classification, output will come in 0 and 1 format or true and false, same like this data set, with whether the loan will be approved or rejected. So it will come as a true and false. So this comes under supervised learning classification model. In the regression side is learning. In case of regression, what we say is that we'll get the predicted value. As for example, what should be the salary of an employee whose experience is 10 years. All right. So that means what I'm getting a value. Same like that. What should be the price of a flat? Right. Like I want to predict using an ML. Right. So you're going to predicting a specific value that comes under regression. Right. There's two types of supervised learning. One is regression, another is called classification. Then we talked about unsupervised learning. And in case of unsupervised learning, we have been given input and we are going to predict the output. Right? No output, we have to predict the output. So this unsupervised learnings are two types. One is called clustering, another is called association. And what we find is that we have been given an input and we're going to predict the output. That means, using an example you can identify, we are going to predict the list of cluster of customer who have a good annual income as well as a high spending score. So based on the input, we are going to predict the list of customer or cluster of customer. So this is one type of clustering, unsupervised learning, right? Like this, we talked about machine learning. Then it say that in case of machine learning, it is used to do the prediction, but the prediction is not accurate. So that's why we are moving from basic machine learning to deep learning, right? So in case of deep learning, what you find is that deep learning is a subset of machine learning. Right? And when you go with deep learning, and what you find is that in case of deep learning, it is going to train the data using multiple layer of artificial neural network. That's what it's said to be as a deep learning. The difference is that in case of machine learning, it is going to find the pattern in the data, and based on the model, we are going to predict. But in case of deep learning, it is going to train the model using artificial neural network, multiple layers of artificial neural network. So in case of deep learning, we moved with different factors. Major factors are like, what we talked about last day is that if you're going to create a deep learning model, supercomputers are required. Feature engineering is built in. We have to train the model with billions of parameters. And for this, we need GPU or TPU type supercomputers. And here some of the open source deep learning models. You can see here ANN, CNN, NLP, CAP, TensorFlow, Theano, right? So whatever deep learning models we have, the core of all deep learning models is artificial neural network, right? So we talked about last day that the scenario is like, how human being learn. Human being learn with the help of neuron. Correct. Now, what we want is that we want machine to learn with the help of neuron. So if you want machine to learn with the help of neuron, what we have to do? We have to create the neuron for machine, right? That is done in the case of artificial neural network. We have to create the neurons for machines, right? And here we talked about that if you are giving an input parameter, that input parameter is passing through multiple layers of neural networks, and we'll get the output values. And here lots of things come into picture. We have the concept of back propagations in case of deep learning. So the purpose is to minimize the value of cost function so that we can get the accurate value based on the input, right? In case of deep learning. So we have given one examples. In case of deep learning, we do the back propagation to modify the weights so that we can get the least value or the correct lowest value of the cost function. As low as the cost function, you will get the accurate output. So like this, we talked about an example last day, right? And gradient descent is used to improve the deep learning with minimizing the cost function. But these are right now, these are not our actual topic of deep learning, right? But we talked about, yes, this is how the deep learning will work. Neural network will work inside our deep learning. Next, we came to our generative AI introduction. And what we talked about in GenAI is that it is a subset of deep learning model. It is used to generate content. It is used to generate new content like text, code, image, audio, video. Examples of GenAI like LLM and LMM, right? Then what we say last day is that GenAI definition, it's a type of artificial intelligence that create new content based on what it is learned from the existing content. Learning from the existing content, right? Now here we talked about that Gen AI is one type of deep learning. So deep learnings are two types. I'm coming into that, but we see that how we can differentiate a deep learning model from a Gen AI. So what we say is that a deep learning model is used to do the prediction. Whether loan will be approved or not, they will predict. What should be the salary of an employee whose experience is 10 years? They're going to predict. What should be the price of a flat? They're going to predict in case of traditional deep learning. And what you're going to do in case of Gen AI? In Gen AI, they're going to create a new content. That is the difference. If you want to get the difference once again that we talked about last day, see here, deep learning is a subset of ML. ML is a subset of AI. So there's two types of deep learning: discriminative and generative. Discriminative side, you'll find artificial neural network, CNN, convolutional neural network, NLP, RNN. Their main purpose is to do some prediction. Whereas the main purpose of this LLM or LMM is to generate the new content, right? So one step ahead, we talked about in Gen AI, we have this, what is the difference between LLM and LMM, right? So LLM means large language model, whereas LMM is large multimodal. We have given one example. We have started our discussion using this example, like Chat GPT 3.5 and examples of LLM, where you'll give the text as an input, you'll get the text as an output. We have given an example last day. We have executed this Chat GPT 3.5. Whereas large multimodal examples of Chat GPT 4. But when I try to use this Chat GPT 4, it is saying that subscription is required, right? We cannot execute last day. But we try to execute the features of LLM using cloud today. So here what happened is that if the input can be on text, image, audio, video, and the output can be as text, image, audio, video, right? That is LMM. But we have not executed an example like LMM. Today we try to execute some example using GCP. We try to execute some examples of LMM today, right? So like this we talked about last day, right? And I told you that to create a registration, to do the registration with OpenAI, and just to check, how this OpenAI actually work, right? So let's move to the next step. In the next step, what we say is that another one difference we talked about is that in case of GenAI, we always get some language, some image, some audio, or some code. Whereas if you get some probability, it is not a GenAI, it is a deep learning. If you're going to do the prediction, right? Okay, so we talked about LLM, LMM. Large language models are very large deep learning models that are pre-trained on vast amount of data. Like our Chat GPT LLM, it is trained with huge amount of data. It's trained with billions of parameters. right? Whereas multi-model deep learning models typically consist of multiple neural networks, each specialized in analyzing a particular modality. Let's explore them. Let's move inside. So this is a slide. It is an examples of multi-model, LMM. So in case of LMM, your prompt can be an image. Your input prompt, in case of LLM, your input prompt is always text and output is always text. But in case of LMM, input can be an image. Based on an input image, you can get a text, you can get another image, or you can get a video, right? So that is, I'm talking about the Gen AI types. Or if you want like this, like input can be in text. Based on the input as text, you can get an image, you can get an audio, you can get some decisions, right? Based on the text, you may get a text, image, or audio, or some other parameter video. That is LMM type, right? Now here, let's move inside, right? Let's go like internal architecture or internally. Yes, we have seen last day how a Gen AI product like Chat GPT LLM, how it is working. Last day we have executed some examples, right? If you write some text that describe sun. So if you write some input prompt based on your input, you can get some output that you have executed last day, right? Based on your prompt. The meaning of life is, it is going to, based on your input prompt, you can get some output, right? It's working fine. Generative AI work. Yes, we have given some input prompt and the LLM is giving us the output. But what happened? What is going on inside the LLM? Right? Whatever the input parameter you give, based on the input, it is giving us some output. Right? So let's move slide inside. Generative AI model learns about pattern in the language through training data, then give some text they predict. So the prompt you can write, the meaning of life is, if it is a prompt, it is giving you some response. No, I want to get some 10 questions of a certification exam, right? And it is given. If you see last day, we got 10 questions, 10 MCQ questions related to a certification exam. Right. Similarly, if I want to send a mail, right, for a specific requirement, GNA is creating a very good mail, and you can use that mail, right? And it is fraction of second, right? Output is ready. But how? How GNA is coming with this output? In any field of area, you'll get some output based on your input. Right? Let's move slide inside. We are talking about how GNI is giving us the output. So here, let's explore some deep learning model. As I told you that internally, the LLM is using multiple deep learning models. Okay, let's explore them one by one. One of the popular deep learning model is natural language processing, NLP. It is the core of our Gen AI, LLM. If you see here, how this NLP work, just see here, NLP combines computational linguistics, machine learning, and deep learning models to process human language. See here, just now You have been given some input inside the LLM. Based on your input, you're getting some output, right? So how this input is processed by your LLM with the help of NLP. See here, when you're giving some input, whatever the input it is, the text is not going inside the LLM. Just see here. There is immediately the moment you are going to submit a prompt, immediately NLP come into picture. NLP is a deep learning model, natural language processing. What NLP will do? Your input text, see here, this input text is not going to LLMs. What it is going is that for each text word, each and every word is being numbered, right? So whenever you are inserting any text inside the LLMs, each and every word is positional number is being identified and it is going to create a feature vector. See here, for each sentence, one feature vectors, each and every word's number positional is being identified and it's going to create a feature vectors. So if you are going to insert 3 sentences, so you can see here 3 feature vectors is going to going inside our LLMs. So when I'm going to insert any text or any word, any sentence inside the LLM, NLP has multiple steps. You go inside the NLP, I've just given here the tokenization. NLP, if you go inside NLP deep learning model, you have multiple steps. Tokenization is the first step. After tokenization, it has the concept called stemming. It has lemmatization, part of a speech, then named entity recognition. Multiple steps are there inside the NLP. I'm not going in depth of that, but when you're going to insert any word sentence, you have to remember that your sentence is not going in the LLMs. For your sentence, each and every word positions one feature vector is going inside the LLMs that contain 0, 1 or its positions, right? Then what should be the next step? Let's see. See how Gen AI work. When you insert any sentence like description, right? NLP immediately come into picture and it will convert your input sentence as a feature vector. And that is going inside your LLM. And your LLM is based on transformer architecture. Transformer architecture contain encoding part and the decoding part. So whatever input is coming, your input sentence is coming as a feature vector inside the transformer architecture. It is passing through a encoding part, then it is passing through the decoding part, then it is moving to your pre-trained transformer model, and then you will get the output. Right? So that means in case of generative AI, one model come into picture that is called transformer architecture. And this transformer architecture is a revolution that today's generation is using with the help of Gen AI. So the question is that from where this transformer architecture come into picture? What it is doing? How this, based on your input, you're getting an output in any field, any area. How this transformer architecture work? What is the internal layers? Means see there is some there is some step-by-step updation of a gradation of deep learnings, right? So what before we come into this directly in the transform architecture, we should have good understanding about different deep learning models. We cannot go in very in depth of deep learning models, but we can give some introductions about the deep learning model, its limitation, how this transform architecture actually work in case of LLMs. It's a very good and excellent modules. If you know this in depth, you can create a genius product for your organization. So let's move inside. Just see here what happened inside the transform architecture. So before coming transform architecture, we are talking about transform architecture using deep learning models. So here, just see, I'm just talking about here. I'll just talked about step by steps how this transform architecture actually came. See, before transform architecture came, let's just talked about some points here. Just see here. So first one algorithm came. Its name is RNN. See, I'm just writing here. This RNN is one type of deep learning model. RNN, its full name is recurrent neural network. It is one type of deep learning model. So using this deep learning model, we can do prediction next word. Let me show you one example. Just see here. I'm going to google.com, and you are going to write here. You are going to write here that we are talking about that in Google, when I'm going to write some word, it is going to do some prediction, right? The next word. How this prediction is done? This prediction is done with the help of a deep learning model. Its name is RNN, recurrent neural network. Recurrent neural network, it can do the predictions of the next word. It's a very good, powerful deep learning model. Now, I'm giving some scenario. This I'm just talking about, right? Now, I've just given you some sentences. Just see here. The transformer are a Japanese band. The band was formed in the 1960s. It's a sentence. There is some gap. It is a gap, just a gap. So just see here. This is the first sentence, and this is the second sentence. In between, the transformer means the band. Right? Now see the second scenario. See here, if you see, the word the band in the second sentence refers to the band, the transformer, introduced in the first sentence. So when you read about the band in the second sentence, you know that it is referencing to the transformer's band. So that, that may be important for translation. There are many examples where words in some sentences refer to the words in the previous sentences. So for translating sentences like that, a model need to figure out this sort of dependencies and connections. And for this RNN come into picture. RNN can, with the help of RNN, that the transformer is the band. How to figure out this? Because RNN can do the prediction for the next word. When there is a gap between two sentences, the band is the transformer. RNN cannot do the prediction. Again, I'm saying, giving you another one scenario. Giving you another one scenario is like this. I grew up in France. There is a gap, means there is multiple sentences in between. Then I speak fluent. That's what should be. It should be French, right? Now the point is that this is one sentence, and this is another one sentence that is coming after some time. And what should be the language? RNN is not the perfect algorithm to do the prediction. RNN is perfect to do the prediction for the next word. In this case, in this example, RNN become very inefficient when the gap between relevant information and the point where it is needed very large, RNN is not successful. This is how it started. Here RNN is successful. But when the gap between two sentences is very high, then RNN is not successful to do the prediction. This is due to the fact that the information is passed at each step and through multiple chains internally, right? So these are the limitations of RNN that you're talking about here. It is very ineffective when the gap between relevant information is very large. Cannot prioritize task. Generally, if you have been given 10 tasks, how you'll execute 10 tasks? You will check that out of 10 tasks whose priority is high, that should get executed first, right? So this is another one limitations for RNN. RNN cannot prioritize task. Not only that, see, we are talking about deep learning models. Deep learning models deal with billions of parameters because you have to train your model with billions of parameters. So when you are training your model billions of parameters, and you cannot think that those executions will be done sequentially, right? If those execution should always be done with parallelism. Parallelism means multiple thread will execute in parallel so that you'll get the output very fast, right? That is another one limitations of RNN is that sequential computation inhibits parallelization. These are the limitations of RNN, recurrent neural network. Right now, to resolve these limitations, another one deep learning model came. Its name is LSTM. LSTM full form is long short-term memory network. Or we can say it is long short-term memory. LSTM. We can say this like this, long short-term memory. Now this LSTM resolved some of the some problems of our last algorithm RNN. See, RNN cannot prioritize task. If you have a 10 task, high priority task should be executed first. That problem is resolved with the help of LSTM. LSTM can selectively remember or forget things that are important and not so important. That is how the problems of RNN is resolved by LSTM. But to some extent, LSTM also not that much of successful. Means when sentences are too long, LSTM also not successful to do the prediction. Sequential computation inhibits parallelization. Same like that, LSTM it does not support parallelization. If you go with sequential computation, it will take long time. You cannot wait long time for deep learning models to execute, right? So after this LSTM, the next algorithm that we find, its name is attention. This attention, just now told you, right? That how we can do the predictions of the next word when there is a big gap between two sentences or multiple sentences. So to resolve this problem, LS attention come into picture. So here researchers created a technique for paying attention to a specific word. See, when you are translating a sentence, I pay special attention to the words I am presently translating. Okay, or when I'm as for example, when you are sitting inside a room, what I'll do, I'll glance around all the objects and describing as I'm sitting inside the room, means paying attention to all the objects, right? So neural network can achieve this behavior with the help of the attention. So it is used to pay attention to specific words in your sentence. Attention can be thought of as a mechanism that weights the importance of different inputs when producing the output. So attention is a technique that is used in neural network, okay, to resolve the problem of RNN. We find this attention. So using attention, we can predict the next word, or we can predict the next word in some other sentence where the gap between the sentences is high or large. So the problems of RNN is resolved with the help of this attention. Now we find another one algorithm that come after attention, that is called self-attention. So in case of self-attention, it is slight advanced than attention. What you're saying is that by applying self-attention, the transformer models can capture the dependencies between different words in the input sequence and learn to focus on most relevant word for each position, so that it can predict the word that is available or that is coming into some other sentence with a gap in between. Now, if you see this diagram, then we find this transformer architecture. So transformer resolve the problem of parallelization using encoder and decoder. Another one told you, right? You cannot execute the data in sequence. You have to execute the data in parallel. So using transform architecture, resolve the concept of parallelization with the help of encoder and decoder architecture. And if you want to see the complete things, see this diagram. This diagram is giving us a complete picture how LLM actually work. In this diagram, if you see, I've just given the diagram for OpenAI Chat GPT LLM. This diagram is equivalent to our OpenAI Chat GPT LLM. If you see this diagram here, it is transform architecture for this LLM when it is started first time. If you see here in the left side, we have encoder. In the right side, we have decoder. According to this Chat GPT LLM architecture, in the left side, we have 6 encoder. In the right side, we have 6 decoder. So initially, the transformer has a similar kind of architecture. Okay. So as you find it here, in the left side, 6 encoder and the right side, 6 decoder. Each encoder is very similar to each other. All decoders are also very similar to each other. That is, they're also very similar, you can see here, each encoder, just see here, each encoder is consists of 2 layers, neural network layer and self-attention layer. So when you're going to insert any text, any sentence, already told you that NLP come into picture. Natural language processing. What it will do, that each sentence, it will define as a feature vector. Each sentence it will create as a feature vector, and that feature vectors will be an input inside your encoder layer. So inside your encoder layer, you have this self-attention layer and then the neural network layer. So encoders input first flow through the self-attention layer. It will help the encoder look at different words in the input sentence as it encodes a specific word. The decoder has both these layers, as well as in between you'll find encoder and decoder attention. Right? So here when you send some input, that input will pass through from NLP with as a feature vectors. It is moving inside the encoder layer. It will pass through 6 encoder layers, as well as it will pass through 6 decoder layers, right? And then we'll get the corresponding output, right? So what you find here, in between it has multiple steps, right? We have different types of attentions. Okay, we have different types of attentions are there. So there is a concept called, so I'm not going into that particular level. Here I'm just talking about that how this transform architecture look like inside your LLMs, right? If you want to explore more, you can explore more into the self-attention layer or the different types of attention, how different attentions work, right? Right? We can go inside in depth. So this is the complete things, if you want to explore more, you can explore more into these layers. In the deep learning side, we talked about how neural network layer will work, right? To the prediction, reducing, minimizing the cost function value. Same like that, you can explore the self-attention layer, how it works with multiple types of attentions, right? Fine. So let's move to the next part. In the next part, we'll talk about a very important term. Its name is hallucination. What is this hallucination? See, we talked about that when you build a model. First of all, this LLM or LMM, any startup organization, they cannot create this type of models because you have to train your model with billions of parameters. So you should have that type of infrastructure throughout the world, right? If the model is not trained properly, then we will not get the proper output based on the prompt. That is called hallucination. Hallucination is saying that hallucinations are the incorrect or misleading results that AI model generate. These errors can be caused by a variety of factors, including insufficient training data, incorrect assumptions made by the model, or bias in the data used to train the model. So if the model is not trained properly, automatically that will not get proper output based on your input prompt. That is called hallucination. Now here, prompt already I told you, it is used to control the output of the model. Quality of your input determine the quality of your output. So how we should write a prompt, right? That we should know, that is called prompt engineering. You can write a prompt there is two types of prompt. One is called bad prompt, another is called good prompt. I'm coming into that. But as you know that the quality of an input determines the quality of our output. So we should write a good prompt so that we'll get a quality output from the LLMs. So how to write a good prompt? What is the difference between prompt, good prompt, and bad prompt? I'm coming into that in the next place. Next, you'll find here that different types of models are there in GCP. Models text to text means you have given input as a text, you'll get an output as a text. Similarly, model types like text to image. You have given some input as a text and you'll get an output as an image. You'll find a model type like text to video, text to 3D. Based on your input text, you will get an output video or 3D. That is LLMs, what you're talking about, right? LMM, right? So text to video models aim to generate video representation from the input text. The input text can be anything from a single sentence to a full script, right? Next, you'll see here text to task. So text to task models are trained to perform a specific task or action based on the text input. The task can be wide range of actions such as answering a question, performing a search, making a prediction, or taking a short of action. So we'll understand our different types of model types, but how this model types will work. Now see, in case of LLM, we use the terms, right? LLM and LMM. So together we talked about foundation model. So use a common term called foundation model. So these foundation models actually being trained with huge amount of text, billions of parameters of text, image, speech, structured data, or 3D symbols. Right? Once the foundation model is trained, then you can give your input prompt, and based on your input prompt, you can get the output. Right? Now here you can see here I'm talking about generative AI from different cloud. Now what we talked about is that we talked about the generative AI solution from OpenAI. That is our Chat GPT because of its very high popularity in the market. We have started our discussions using this. Now let's move based on this, the generative AI popularity, and it is being used in all sphere of business. It is being used in HR side, in sales side, marketing side, entertainment industry, medical industry, right, trading industry, all sphere of business. GenAI started to use, and lots of company being created based on GenAI implementation. So here we are talking about based on the popularity of GenAI, based on the performance of GenAI, cloud also came with the GenAI solution. All the clouds. So you can see here Azure came with the GenAI solution. Its name is Azure OpenAI. This Azure OpenAI is not the OpenAI from company. OpenAI and Azure together created Azure OpenAI. It is not the OpenAI Chat GPT. So Azure OpenAI is completely different from the OpenAI that you find. So this Azure OpenAI, it came from the Microsoft Azure. From AWS, we find AWS Bedrock. It's a platform where you'll find all the LLMs and LMM. Similarly, for GCP, you'll find Vertex CI and Gemini. It's a platform where you'll find all LLMs and LMM of Google Cloud. So you can say that this is a GenAI solution from different cloud. And you should know how to use these GenAI solutions from different cloud. So let's see some more input here. Let's generative AI from GCP. If I'm talking about, we have lots of models. We have lots of LLMs and LMM that came from GCP. We define them as Vertex AI Foundation models. It's a platform where all the LLM and LMMs are there. Similarly, you can see here code generation models. This is another one revolution from developer side point of view. Just before few years back, developer can never think that his or her code will be generated by someone. So this is one type of revolution. That your code, the code that you're going to write, you don't have to write a code, just write the text, what type of code you want. Based on your input text, it is going to generate the code based on your requirement. So based on your input prompt, this code generation models can generate the code. From Microsoft Azure, we have GitHub Copilot. From AWS, we have AWS Code Whisper. From GCP, we have Duet AI. Now, this data that you find, it may not be correct today, because these GenAI solutions are updating every day. Every day you'll find something new. So from Microsoft Azure, we'll find GitHub Copilot. From AWS, we have AWS Code Whisper. We'll say that how to use this code generation tool to generate our code. Right? We'll give some demo. Next, you'll find here GenAI tools. These are the popular tools that you find in the market. Image to text, you'll find GPT-4. That is our Chat GPT-4. Right? For image to text. If you want to create video based on text, we have Runway ML. If you want to get or solve any problems, you'll find Chat GPT. You can write anything, you can write Sonic. If you want to generate some art, we have Midjourney or DALL-E. If you want to generate some code, we have Replit. Do you have to generate some music? We have SoundRaw. If you want to generate some TikTok video, you'll find Flicky. For generating PPT, we have Slide AI. To edit videos, we have Pictory. And to edit picture, we have Remini. These are some of the popular Gen AI solution that is being used throughout the world. So just mentions. Now let's understand some more inputs about this LLM. Chat GPT is the LLM from OpenAI. Let's get some more input, though we have executed last day. Let's get some more input about it. Now here Chat GPT, it's an AI chatbot developed by OpenAI and built on top of OpenAI Chat GPT-3. What Chat GPT have a reinforcement pattern is that it can learn conversation pattern and store it in a conversational history. It can learn itself. When I'm going to insert some prompt, your Chat GPT model can, or the LLM can learn itself based on your input. Now here, there is some of the details that already you know, that we have Chat GPT 2 version currently fine, 3 and 4, but there is a huge work going on in the release of Chat GPT 5. It's developed and maintained by OpenAI. It's owned by OpenAI. So earlier OpenAI was a non-profit company, but it started to get profitable from the year 2019. And you know the CEO Sam. So it is trained with huge amount of data, right? Now we talked about prompt. So it's a process of creating prompts that elicit a desired response from a language model. It involves human writing, refining and prioritizing prompts in a structured way. Now here, how can differentiate between Chat GPT and GenAI? So already told you, it is one type of LLM, right? So Chat GPT is one type of LLM, correct? So generative AI is a broader field that encompasses techniques for generating diverse types of content, while a Chat GPT is a specific implementation focused on conversational interaction, right? Now here, the important things that come into picture, that is prompt engineering. Just now told you that based on your quality input will give you the quality output. That is the prompt, or you can say prompt engineering. Right now, Now, how we can create a prompt? What should be the approach? Let's explore this one. So here we're talking about that prompt design. See the scenario like write an email to a developer team of an IT organization, inviting them to change cloud native workshop schedule by learning and development team. So this is a prompt. This is a prompt. So you need a particular mail. Assume you are working in the HR domain. So you need a particular mail and you have to write a mail, right? So what you'll do is that you'll just copy this, Control C, and I'm going to write this prompt here, Control V. Just see here. You have given a prompt and the Chat GPT is creating a mail. That is the old schedule, that is the new schedule, right? And you are writing a mail and you can see in a fraction of a second, mail is ready. Dear developer team, I hope this mail finds you well. I'm writing on behalf of this, and this is our old schedule. This is the new schedule, right? Like this, you send a mail. And in a fraction of a second, you can see it's generating a mail based on your prompt. Now the mail that you find, yes, you can use it. But when I talked about, mail in corporate level and corporate business, if you see this mail, it is not into that quality mail as we used in corporate sector. You'll not find the fun tone. You'll not find the friendly tone, right? You'll not find emojis. It is not that much of crisper, right? So, in corporate level, this type of mail is avoided, you can say. So what I'm talking about is that the prompt that you have used, this is called a bad prompt. You have used a prompt, you got the output. But this is not a good prompt. Yes, you have written a prompt, you got some output, but we need a good prompt. We need a prompt that will give us some quality corporate-like output. Right? So then how to create a good prompt? So how we can create a good prompt? So there is an approach to write a good prompt. Create your prompt, follow the following steps. When you want to write a good prompt, you have to divide your prompt into this 4 parts. This is one standard. The prompt should have a context part. The prompt should have a text part. The prompt should have an instruction part and the data part. Whenever you write any prompt, I'm just saying the examples using this. The prompt engineering is saying that you should write a good prompt. So how to write a good prompt? We have to divide. When we're going to write the prompt, we have to write the prompt in this 4 category of layer. So the current example just now I told you that we have to write an email to the developer team of an IT organization, inviting them to change cloud native workshop schedule by learning and development team. So this prompt we should write in a 4 layers, like context, task, instructions, and data. How to write it? Just see there. In the context part, you can write like you are an experienced HR professional expert, an email copywriter who has written HR content for brand like Oracle or IBM or Google. In the text part, you can write an email to a developer team of an IT organization, inviting to them to change cloud native workshop schedule by learning and development team. In the instruction part, right, the content should be formal and designed to resonate with an audience of experienced IT professionals. Try to figure out the way around Chat GPT. Focus a lot of users who are working in the software development role. In the data part, you can write it include a review from someone who said the session is no-brainer for someone who want to stay relevant in the year 2023 or 2024 and beyond. So like this way, you should divide text here. This is the context part. So copy this context part. Control V. Next, copy this task part. Next, copy this instruction part. Next, copy this data part. Right, we have given. Now just execute and check. See here, this time, if you see this output, which is much more better compared to earlier. Just see here, subject, dear esteemed software development team, trust the message find you good. And you can see here the writing style, the text is much more different from the earlier approach. You see, it's slightly different. It's much more good quality compared to the earlier. And if you want to know, I don't need this much of big text, I want to shorter. So what you can do is that you can short this. Then you can write like this. Can you make the above shorter and crisper and not more than 300 words. Generally, ChatGPT, response will come from 400 to 4000. Limit I'm talking about in this limit of words. So I need it like this. Let me check if it is doing or not. Yes, you can see here. So, based on input, you can tune, right, the output, right? Now you have done to some extent with for 300 words. Now what I want is that I want the tone slide friendly, as well as I want to input some emojis also when I'm going to write some mail. So you can write like, can you make the overall tone, overall tone, fun, and emojis and make the tone friendly. Let me check. Yes, you can see here the same mail is coming with emojis, right? Much more better. So like this way, you can fine tune your output that is coming from the LLMs, right? If quality output, we should use quality prompt and we'll get a quality output, right? And in that case, we can use this approach, can divide the input prompt into 4 parts: context, text, instruction, and data. And you'll get a quality output. That is one part of prompt engineering, how to write a good prompt, right? Right, so this is the scenario. So next, we are talking about our next topic is Gen AI or generative AI using cloud. So still now we talked about Chat GPT, that's an OpenAI LLM, and how we can write a prompt as an input inside the Chat GPT. Right now we're moving with this generative AI solution from cloud. Just now told you that we have the GenAI solution from AWS, we have GenAI solution from GCP, we have the GenAI solution from Azure. In this examples, we'll talk about the GenAI solution from GCP first. Today, we talked about GCP. Tomorrow, we try to explore GenAI solution from AWS and Azure. Fine. So when talking about GenAI solution from GCP, we have to say here LLMs with GCP. So still now we talked about LLM as a Chat GPT LLM. Now I'm talking about LLMs with GCP. Now, as you know that LLMs are trained to solve some common language problems. We can do text classification, question answering, document summarization, text generation. And these LLMs can solve problems in the field of retail, HR, finance, and entertainment. Just now, we have given some example, right? How ChatGPT being used in the HR domain. Same like that, you can use LLMs in GCP in different sphere of business. Now, here we can see some of the LLM example like Palm. It is one of the popular LLMs that is being created in April 2022, and it is being trained with 550 billion parameters. It is based on transformer model. Just now we've given you the transformer architecture, right? Similarly, Bird, another one, LLM's chatbot created by Google AI. So let's understand when talking about LLM using GCP, let's take the complete hierarchy. What are the different types of LLMs created by GCP? Let's get some overall idea. If you see this diagram, it will give you complete view of different LLMs. If you see here, first they came with a transformer architecture that came in the year 2017. Then you'll find in the 2018 Bird. Bidirectional encoder representation from transformer. World first language model. Open source by Google in the year 2018. Then you find T5. It is text-to-text transformer model and it is being trained with 10 billion parameters. open source by Google in the year 2019. Then you find Lambda in the year 2020. It is based on dialogue applications published in the year 2020. We find Palm. Palm is related to image generation based on the text, hence LMM type. Based on the physics, one of the module called diffusion theory, it is being trained with 550 billion parameters, released in the year 2021. Then you find in the 2022 CAL, Confident Adapted Language Modeling. Right? Then you will find in 2023 BERT, Conversational AI Service powered by Lambda. So if you see here that different types of LLMs and LM or LMM created by Google. In the 2024, you'll find Gemini. Same naming convention change, they have updated. Version is Gemini that I have not mentioned here, right? So when you implement some labs, you'll see the Gemini, right? So these are different LLMs and LMM from GCP, right? Now we should do some explore, right? Now where I'll get all these LLMs on the GCP, all the LLMs and LMMs will come under Vertex AI Studio in GCP. Right? So let's see, right? Before going into the next level, let's see how we can interact with LMM using GCP. Now you can see here we are directly inside our GCP. So inside the GCP directly, I'm going inside our Vertex AI Studio. You can see here Vertex AI, and from Vertex AI you can go to dashboard. Go inside Vertex AI dashboard. In the left side, you'll find Vertex AI Studio. See here, you'll find Vertex AI Studio. So all the LLM and LMMs, all the GenAI solutions you'll find under this Vertex AI Studio. Let's see first this language. And you can see text generation is there. So let's use text prompt. So you'll write some prompt, you'll get a response, same as you have done in Chat GPT. So you can see I'm just writing describe sun. We're going to submit and see based on an input prompt, it is going to return some output like sun size and distance, temperature, then structure, activity cycles, importance to life on Earth, further exploration, right? Like this way it came. So based on an input prompt, you get some response. Same things we got in Chat GPT also, right? So it is one type of LLM, right? And you can see it is using the LLM, its name is Gemini. See in the right side, Gemini. The moment you have executed this Gemini deployed in, it is running inside a region. And these are some of the parameters like temperature. Temperature control the degree of randomness in token selection. Lower temperature are good for the prompts that expect a true or correct response. Where, right? Where, you'll find another parameter called output token limits. Output token limits determine the maximum amount of text output from one prompt. A token is approximately the 4 features. So you can see how you're going to write. If you're going to increase this based on that number of words, it will also increase, right? Whereas in case of Chat GPT, minimum size of your output is 400 to 4,000 words in Chat GPT. Whereas in case of GCP, you can Gemini, you can see Now here you can see what you're talking about is that we are talking about the GenAI solution from GCP using Gemini, right? Now, this already you have done with the help of Chat GPT. Based on your input text, you'll got a response, output text, right? So that is already you have done in Chat GPT 3.5. Now we'll give you some examples of LMM type. Now you can go into multi-model. You go inside the multi-model. Here you'll get some examples of LMM. We try to use some LMM, means based on your text, you'll get some image. From the image, you'll get some text. From the video, you're going to get some text, right? That is LMM, right? But we tried to do it some LMM last day, right? Using GPT-4, but we need some subscription, right? That's why we've not executed the same. So today we'll try to execute the LLM with the help of GCP in the Vertex AI Studio, right? Now you can see if you go with multi-model, just see here, we have been given some predefined examples. You can use this example. Just see here, I'm using some predefined example, like see here, this is an image that have some text, right? So what I want to do, the input prompt, I want to use an image, and output should be in text. So image to text. Let's see how I can do it. So if you click open, just see here. If you click open, just see here, the prompt is an image. It's already given to us. We're just going to execute and check. We have an input image I've already given. So you're going to use an input image, given image, and what is the text is there inside the image that I want to extract. Right? Let me check. If you click submit, so you're using this image as a input prompt, and it is returning in text. The text is the best dream happens when you are awake. So the text is written here. I want to extract the text from this image. Right? Let me take another one example. Another one example, like if you see here, we have some. Let's take some video. We have some video, right? Get an activity that is being performed in the exercise video, asking a question, or get a description of the content of the rock climbing video. So we have some video, right? What do you want? This video I want to use as a prompt, and I want to generate some text. So this is what? Video to text. It is one type of LMM. Let me execute. Click open. So you can see this is the video. Now what I want to do, what are things is described in the video, I want to get it in the text. So it is video to text, right? So if I want to get video to text, right? So you just click submit. See, it is using the Gemini, and click submit. And you can see whatever text is there, you got some text from this video. Right now, you can create your own video. That also you can use. You can see here it is saying insert media upload from the computer. File size 7 MB. Import from the cloud storage. So they have given some limit because you are going to use this, right? So this is the predefined videos. If you want, you can include your own videos with this limit as they have given, right? Same like that. Let me just check another one. Multi-model. What it is saying, generate a description of the diagram. so that it can be indexed and search over. So you have been given one diagram. It's an image, right? We want a description from this image, right? So let's open. If this is an image, okay, they're asking for certificate. Okay, send the certificate. Now click submit. Now see here the image I've submitted, and you can see here shared people vaccinated against COVID-19. This is the report, right? So some graph is given here. See here. So this data can represent like this way, and this is an excellent format, right? So right, you can get the text from a graph or chart, right? Similarly, this is what multilingual LMM, right? Let me get some more examples here. It is saying that write a story from an image. So you're going to insert an image, it's going to return a story. Let's see. So write a creative story inspired by a story inspired by an image, right? So this is what? This is an image, right? From this image, we want to generate a text. So click submit. So I'm going to generate text that's going to describe this image, right? You can see here it is generating a text to describe this image. Okay, so it's right like this way. You can execute any one of the LLMs and you can check, right? They have given a very good and excellent examples. You can explore these examples of LLMs, right? We'll get a very good understanding GenAI using GCP, right? So that you're talking about in this example till today. So till today, we're talking about LLM and LMM with GCP, right? Cloud, you can see the examples. So tomorrow or the next day, we'll talk about LLM and LMM using AWS and Azure, as well as we'll talk about the RAG implementation with LLMs. So till today, we talked about LLMs and LMM with GCP, right? So I'll suggest is that, right? Fine. So I'll suggest that you can try the same things from your end. So you can see here what you have done today is that we talked about the internal architecture. We talked about this part, OpenAI solutions, about Chat GPT, some introduction. Then we talked about the difference between bad prompt and the good prompt, how to write a good prompt, right? Then I create a short prompt, right? Then we talked about limitations of GPT-4 means. There's the limitations of GPT-4 also. Let me just show you the limitations. First of all, the limitation is that, it cannot generate a text more than 4,000 words. It will not get this GPT-3. Another is that, let me just write one question. Just see here. What is the stock price of Wipro, okay, in Indian stock market? Let's see here. Let's see this. See here what it is saying. I don't have real-time internet access to fetch current stock prices. That means the LLM that I'm going to interact with, same things. Let me just use the LLMs from GCP. Same things I'm using from LLM from GCP. Okay. Language, prompt. I'm writing here. Just see here. Submit. See here what it is saying. It is coming some text. See here what it is saying. November 21st, 2023, the stock was this much. Right? So I need the stock price of today in the 2024, 16th April. It is giving some old value. That means what the problem is that our LLMs will not get real-time data. You're getting the data here. See, it is giving the data, but this data is 2023 November. 6 months old data. You're not getting the real-time data. You need the real-time data of today. That is one of the limitations of the LLMs. Either Chat GPT or the LLMs that is created with the help of GCP. You will not get the real-time data. Right? So GCP product is GCP Gen AI solutions will get inside Vertex AI Studio. LLMs is the Gemini. How to connect with GCP is that you have to create an account. Okay. So first you should have a Gmail ID, right? You should have an account. Then you have to go to Cloud Console. If you have an account, you have to go to Cloud Console. And let me show you here itself. Let me just log out and once again log in. First, you have to create an account, GCP account. Okay. So you have a Gmail ID. So I'm going to log in using this Gmail ID because I should have a Gmail ID to access my Cloud Console. Right. So just logged in. Now what I have to do is that I came inside my Cloud Console. If you have just logged in, you cannot use the GCP services. To access GCP services, who knows is fine, who don't know, for them just saying is that you have to create a billing account. You have just done the registration and login, came inside your dashboard. That does not mean that you can use the GCP services. To access the GCP services, what you have to do is that you have to create a billing account. So how to create a billing account? To create a billing account, you have to write here. In the left side, you'll find manage billing account. See here, you have one option called create account. Right, you have to click create account, then move continue. And you have to validate. You have to validate yourself with your credit card. They are going to deduct 2 Indian rupees, Indian currencies, and for validation purpose only, 2 rupees. And the next working day, they will refund it back. Right? So like this way, you have to create a billing account first. Right? You should have a key to create a billing. You have to create it, else you cannot use any GCP service. So you can see in these examples, already I have created one billing account, my billing account 4, and it is an active. So you should have an active billing account if you want to use any GCP service, right? So once you create a billing account, they will give the approval. GCP team is there on the other side. They will give you approval. Once they will give you the approval, you'll find the billing account as active. So next, you have to create a project and enable the project using the billing account. How to create the project? You have to go to dashboard. And the right side, you'll find the options called create project. You click here, create project, and create. You have to create a project. Just see here, create project, my project 8628. That's it. Project creation is done. Right? So the next step is that you have to create a project. Then enable the project using the billing account. If you want, you can write the option here. Step number 4, create project. Then step number 5, enable the project under billing account. Step number 6, use it in the Vertex here. So enable the project under billing account means what? Just now I've created the project, right? 8628, right? So let me come into that billing part, manage billing account. And you can see here projects. Once project created, this is the project just now I've created, right? And you can see the billing account enabled it is, right? By default, it is coming because you have an active billing account, right? Now, if you don't want billing account, if you are working in a particular project, that project is not business requirement, you are using for training purpose, right? So if you're not using GCP, you should always disable it. Disable billing for your project. Else it will automatically deduct an amount from your credit card, right? So till the time you're using a specific service under a particular project, enable that particular project using the billing account. If you're not using it, just disable it. Right? So currently you can see this project is enabled with this billing account. Right? Then you can use any service. Right? So that you're talking about here is that if you enable the project under billing account, then you can use Vertex AI Studio. Right? So this is the things 2 scenario you talked about, how we can use generative AI using Chat GPT as well as using GCP.